Okay, section 5.5, logarithmic functions. Nothing in this lesson should be new either. Okay, a lot of this you did study last year in Honors Algebra 2. All right, so what's a logarithmic function? A logarithmic function is exactly this. It's our log, base A of B is X. That's how we would read that. Now notice this double-sided arrow. Logarithmic functions are directly related to exponential functions because they are inverses of each other. And we'll talk about this again later on in the video. So what this means, and something that you've studied, if you have log base 2 of x equals 3, then I can write that logarithm as an exponential function in order to be able to solve it. So last year, I'm sure a lot of you looked at it like what we would say is the fish hook. Base raised to the answer equals the expression. So 2 raised to the third power would equal x, and therefore we can evaluate this function and simply get our answer of 8. So now going backwards though, if I say start with an exponential function, so if I have 2 raised to the x power is equal to 12. Now this problem I can't solve without the aid of a calculator. 12 cannot be rewritten as 2 raised to some power. So in order to solve that, I would take my exponential function and I would write it as a logarithmic function. So notice the rules. The bases are the same, so log base 2. My exponent is now my answer, and my answer becomes my expression. So log base 2 of 12 equals x. Now solving this, we'll get into at the end of a little bit closer to the end of the chapter, but just so you're aware, they work both ways. If I'm given a logarithmic function, I write it as an exponential function to solve. If I'm given an exponential function that I cannot solve without a calculator, I would write it as a logarithmic function. Okay, so we'll do domain and range, and again, that'll pop up again. But if I look here, this is an exponential function. This is one of the parent functions we studied. So I'm either going to have exponential growth or exponential decay. Both domains are all real numbers. Okay, my input can be any real number. My range here, and I'm going to use the letters of the expression. So just for this case, I'm going to use B. Okay, B is my output here. That's what my equation's equal to. My range have to be positive numbers. Okay, so if that's the domain and range of your exponential function, recall how domains and ranges of inverse functions are related. The range of the function becomes the domain of the inverse, and the domain of the function becomes the range of the inverse. So now the logarithmic function, my outputs can be all real numbers, but my inputs, and I'm using the letter B, have to be greater than 0. So you cannot take the log of a negative number or 0, and we'll look at a lot more examples using these properties. Okay, so evaluating without a calculator. Now notice these aren't equations. You can very simply make these expressions into equations. So I'm going to put that equal to x. How do we solve a logarithmic function? We write it as an exponential function. So I'm going to take my base, 4 raised to the x power equals 16. 4 raised to the x power equals 16. Now without the aid of a calculator, we know that that answer is just simply 2. Next one, set it equal to x until you are comfortable with evaluating these. 2 raised to the x power is equal to 1/8. Now we just did these last lesson. This is what your first quiz was on. Now 1/8, I have to think, can I rewrite that in base 2? Which we can. We can write 1/8 as 2 raised to the negative third power. So what does that evaluate? What does my original evaluate to? Negative 3. Okay, example 3. 36 to what power would give me 36? So my exponent would just simply be 1. Log base 5 of negative 25. So if you're in the zone here, trying to answer as many questions as possible, this is what the exponential function would look like. You can't raise 5 to some power and get a negative output. So remember, the domain of your logarithmic function, your inputs have to be positive numbers. So number 4 has no solution. Okay, next one, base is 1/3 raised to the x power equals 9. So now let's relate the bases. 1/3 can be written as 3 to the negative 1. 9 can be rewritten as 3 squared. So then I would have 3 to the negative x equals 3 squared. Setting my exponents equal to each other and solving for x, that would give me an exponent of, or an answer, excuse me, of -2. Now, again, as you get used to these and you have a whole lot of practice problems for these, you don't necessarily have to write this equation here, okay? If you can answer it and just evaluate it, you're done. But if you need the aid of the equation, it's there to help. Okay, so now let's check this out. There's no base here, okay? And this is going to be the next slide, so spoiler alert here. When the base is not written, we know it to be base 10. It's called our common log. That's what we'll look at next slide. So when I take this and I write it as my exponential function, I have 10 to the x power is equal to 1. Well, what exponent evaluates anything to 1? That would be an exponent of 0. Okay, so log rules. Your common log is your base 10. Okay, so when your log is base 10, we don't write it. This is how you would see it, just like we did on the last example. This is also the button on your calculator. Okay, so a couple rules. When the base of the logarithm and the base of the exponent are the same, you have to think that they undo each other. So this would just evaluate to 1. Why? I can always check a logarithmic by writing it as an exponential, because b to the first power would equal b. Log base b of 1. No matter what the base is, this will always evaluate to 0. Why? Because b to the 0 power, anything to the 0 power is always equal to 1. Okay, next, let's check out what's happening here. My bases are exactly the same, so my exponent's going to be a 1, but now I go from a whole number to a fraction, so that's going to make my exponent a negative. So as a check, why is this true? Because b to the negative 1 equals 1 over b. Okay, lastly, you may be able to recognize what this is equal to, but I'm going to think b raised to what power will give me the square root of b. Okay, so my bases are there. Now I just need to get the exponents to be equal. So the square root is the same as the 1/2 power. So log base b of the square root of b would just evaluate to 1/2. Okay, and that property really uses a lot of what we just did here, where we need you to see that when these are the same, they cancel each other out, and you're just left with what the exponent would be equal to. Okay, so next, logarithmic functions. The graphs of them. So below is the graph of 2 to the x power. Determine the inverse function. All right, determining an inverse. Replace f of x with y. Switch the position of x and y, and now you have to solve for the new y. Well, this is an exponential equation. How do I solve an exponential equation? I use logarithms for that. So writing this as a logarithmic, log base 2, because the base of the expression and the base of the log are always the same, of x equals y. Now just replacing y with my inverse notation. So now there's my inverse function, okay? Let me skip up to the next slide here. So now notice what's happening. So again, we looked at the domain and range. If the domain of the exponential function is all real numbers, that means the range of the log function is all real numbers. If the range of my exponential function is y is greater than 0, that means the domain of my logarithmic function is x is greater than 0. And there's a couple other things that we had learned. Okay, if the point 0, 1 is a y-intercept on the graph of f of x, then the point 1, 0 is the x-intercept on the graph of the inverse function. Sorry that the pen keeps doing this. So on the graph of my logarithmic function, I have a horizontal asymptote at the line y is equal to 0. Okay, that's the x-axis. Now on the graph of my inverse function, I'm going to have a vertical asymptote at the line x is equal to 0. So last year in Algebra 2, you spent a lot of time graphing exponential functions. So we will look more at the graph of your logarithmic functions as well. All right, so this I had already mentioned. These functions are inverses of each other. So now we're just looking at it in function notation instead of using a, b, and x. Now the one thing that I do want you to add, this double-sided arrow means it works both ways. So if I start with an exponential function, my inverse is a logarithmic function, and vice versa. If I originally start with a logarithmic function, then its inverse, because of this double-sided arrow, its inverse would be an exponential function. Okay, so they are each other's inverses. If you start with one, you write it in the other form to solve it. Okay, determine the inverse. I'm not going to graph these on the video, but what would my inverse function be here? So my original starts as an exponential, so its inverse is a log. Log base 1/2 of x. That would be my inverse function because my original is an exponential. So then number 8, I start with a logarithmic function. Now notice here our base isn't written, so we know the base to be 10. That's our common log. So my inverse function would be 10 to the x power, the exponential function associated with the base of 10. Okay, so if common logs are log base 10 of x, and we don't write the base, your natural log is log base e. We don't write the base, and not only do we not write the base, but this, and let's add x in there, we represent the natural log as we would read this the ln, okay, the ln of x. So now these are logarithms, so we solve them the exact same way. So if I need to set this equal to x, what's the natural log? The natural log is log base e. Writing that in exponential form, e to the x power is equal to e to the 5th. So what does this evaluate to? X is equal to 5. ln of e, okay, natural log is log base e. If I set that equal to x, I get e to the x is equal to e. When that's not written, we know the exponent to be a 1, so I get x is equal to 1. And then lastly, I have log base e of the square root of e is equal to x. Okay, writing that as an exponential function. Now remember, the square root is the same as the 1/2 power, so this function, expression in number 11, would evaluate to a half. Now we want you to get used to using the properties. And again, this will come with practice. But when the base of the logarithmic function and the base of the expression are the same, it's like they cancel each other out and you're just left with the exponent. Natural log of e is always going to be equal to 1. Why is that true? Because e to the 1st power is going to give me e. Natural log of 1, we said this on one of the first slides. No matter what the base is, it'll always evaluate to 0 because anything to the 0 power is going to give us 1. That'll do it for this video.